Hey everyone, welcome back to Edgeverse. Imagine a single company controlling almost the entire backbone of the AI revolution. One company that every major tech giant, Google, Amazon, Microsoft, Meta, relies on to train their massive models and run their AI services. That company is NVIDIA. Right now, in late 2025, they're sitting on a $500 billion order backlog, with projections to pull in over $300 billion in data center revenue next year alone. Insane, right? But here's the thing. The biggest players in tech are quietly building their own custom chips to break free from NVIDIA's grip. Billions are pouring into secret projects designed to slash costs, save power, and take back control. So, is NVIDIA's throne unbreakable, or are we watching the beginning of the end for their monopoly? Today, we're diving deep into the brutal competition in the AI chip wars. Stick around. This is going to be wild. Let's jump in. First, let's set the stage. Why did NVIDIA become the king of AI chips in the first place? It all started back in 2012. A team at the University of Toronto used NVIDIA GPUs to crush the ImageNet competition, a huge computer vision challenge. They won by a massive margin, proving that GPUs, originally built for gaming graphics, were perfect for the parallel math that powers deep learning. On screen, side-by-side comparison, CPU versus GPU architecture. From that moment, NVIDIA's CUDA software platform became the gold standard. Millions of developers learned it, thousands of AI libraries were built on it, and suddenly switching away felt impossible. It's like trying to rewrite all your apps from iPhone to Android overnight, except 1,000 times harder and more expensive. Fast forward to today. NVIDIA's fiscal 2025 revenue hit $130 billion, more than double the year before. Their data center segment, almost entirely AI chips, is printing money with 75% gross margins. 75%. That's pricing power most companies can only dream of. And the demand? Unreal. They've got a $500 billion backlog stretching into 2026. Cloud providers, enterprises, startups. Everyone's lining up for Blackwell GPUs, the latest architecture that delivers roughly 10 times the performance of the previous generation while using less power. On screen, Blackwell chip render or spec comparison chart. So yeah, NVIDIA is dominant. Some estimates put their market share in AI accelerators between 70 and 95%. But here's the big question. How long can that last when the richest companies on Earth are gunning for them? Let's talk about the hyperscalers. Google, Amazon, Microsoft, Meta, the cloud giants that run the internet. These companies spend tens of billions on AI compute every year. For them, even small improvements add up to hundreds of millions in savings. There are four main reasons they're going all in on custom silicon. First, cost. NVIDIA charges premium prices because they can. But if you're running millions of AI queries a day, a custom chip that does the same job for 10 to 20% less cost pays for its entire billion-dollar development in just a couple years. Second, power efficiency. Data centers are power hogs, and electricity bills are exploding. A custom ASIC, application-specific integrated circuit, can be laser-focused on one task, like inference, and use way less electricity than a general-purpose GPU. As power becomes the new bottleneck for building bigger data centers, this advantage gets huge. On screen, graphics showing GPU versus ASIC power consumption for inference. Third, independence. Relying on one supplier is risky. What if there's a shortage? What if prices go up? What if geopolitics messes with supply? Custom chips give them control and bargaining power. And fourth, optimization. Every company's AI workloads are a little different. A chip built specifically for your exact needs just performs better. The catch? Designing a cutting-edge AI chip costs anywhere from $200 million to over $1 billion. Only the biggest players can afford that bet. Smaller companies? They're stuck buying NVIDIA. So who's actually building these custom chips? Let's break down the heavy hitters. Starting with the pioneer, Google. They launched the Tensor Processing Unit, the TPU, back in 2015, a full decade ago. Today they're on version 7, called Ironwood. Google used TPUs to train the original transformer model that basically invented modern large language models. They've even partnered with Anthropic to potentially deploy up to 1 million TPUs for training Claude. That's serious scale. And because Google controls both the chip and Google Cloud, they can optimize everything together for insane price performance. Next, Amazon Web Services. They've taken a two-pronged approach. Inferentia for inference, launched in 2018, and Trainium for training, launched in 2022. Here's a big win. Anthropic is reportedly using 500,000 Trainium 2 chips, and some AWS data centers are running pure Trainium clusters with 0 NVIDIA GPUs. That's a direct replacement in training, which everyone thought was NVIDIA's safest territory. Microsoft is quieter, but their Project Maya chips are tailored for Azure workloads and their own AI research. Meta has the MTIA, Meta Training and Inference Accelerator, built for the massive recommendation models and LLMs they run daily. And even OpenAI, creators of ChatGPT, is working with Broadcom on custom chips expected in 2026. They clearly want off the NVIDIA treadmill too. Then there's AMD, trying to compete with general-purpose GPUs like the Instinct series. They're cheaper and sometimes match NVIDIA on raw performance, but their software platform, ROCm, just isn't as mature as CUDA. Most developers still pick NVIDIA because the ecosystem is better. On screen, timeline or grid comparing Google TPU, AWS Trainium/Inferentia, NVIDIA Blackwell, AMD Instinct. Quick mention of two other categories, NPUs and FPGAs. NPUs, like Apple's Neural Engine, Qualcomm's and Snapdragon, Intel and AMD's and laptops, are for on-device AI. Think real-time photo editing or voice assistants on your phone. Totally different market, growing fast as privacy and latency matter more. FPGAs are reprogrammable chips, great when you're not sure exactly what workload you'll run. But they're less efficient than GPUs or ASICs, so they stay niche. So is NVIDIA doomed? Not even close. Their biggest moat is still CUDA. Rewriting code for another platform is painful and expensive. They innovate crazy fast, new architecture every 2 years. They have deep partnerships with every major cloud provider, and their cash flow lets them outspend everyone on R&D. But the threat is real. Inference is the biggest and fastest growing workload, and that's exactly where custom ASICs shine. As models mature, more compute shifts from training to inference. Hyperscalers are already using a best-of-both-worlds strategy. NVIDIA for cutting-edge training, their own chips for high-volume inference. Here's my take. We're heading toward competitive coexistence, not a knockout. NVIDIA will stay the dominant player, probably dropping to 50 to 60% market share by 2030, but that's still massive. Custom silicon will chip away at the inference side, especially as power constraints bite harder and software for these new chips gets better. The winners? The hyperscalers who can afford their own chips. The losers? Smaller companies locked into whatever the giants offer. What do you think? Is NVIDIA's moat unbreakable, or will custom silicon actually dethrone them in a few years? Drop your thoughts in the comments. I read them all. If you enjoyed this deep dive, smash that like button, subscribe, and hit the bell so you don't miss the next one. We've got more AI wars coming soon. Thanks for watching, and I'll catch you in the next video.